promise you this circus does have functional robots. And to prove it, we have Gwen's team with the obstacle detector.
This is my team, robot obstacle detector, Gwen, me, Abbas, Cedric, and Ro. Our vehicles, the electronic smart Bluetooth robot is designed for competition and for education. This vehicle is basically detected or supported by IR remote controller and mobile app. And this is a fun way of presenting audio and robotic. And this robotic usually used for school projects and education and etc. Yeah, I'm gonna pass to Rob.
Once again, my name is Ro. I'll be going over kind of how we put things together and essentially what is in our robot car. The robot car essentially consists of the circuit board with microcontrollers in it, which is essentially like mini computers. So it sends the information to each separate function. We have the ultrasonic sensor. It sends a signal out, bounces back off the object, comes back in, so the robot knows that there is an obstacle in front of it. Oh yeah, and we also have a Bluetooth module which gives it Bluetooth functionality, so we can connect to it using Bluetooth. There's also a line tracker underneath, actually, so it can follow dark lines, and I think it can also follow soft white lines as well. And yeah, essentially it was pretty simple to put together, pretty easy. So I'll now pass it on to Seti or Abbas for the code.
So this is basically detecting obstacles. We used servo motor. There is a microcontroller called Arduino Uno. So basically, this kind of kits comes with preloaded libraries, which means that we have already UC motor.h and servo.h. So we don't have to like write code for those. Those are preloaded libraries. It's a generic library for Arduino Uno. So we just load that. What we basically did on this robot is so we have a loop here. So there's like two serial ports that like helps this robot to detect stuff. One is the line tracking sensor over here, and this is a motion detector. So whenever like any motion comes over here, it just gives it a serial through the serial port. So like the serial port detects the number and it matches with the serial port here. Then the car starts detected and like detects and start to like move away from the condition. If that condition doesn't satisfy, it just goes down slowly. Generally, the motion detected, if the motion is detected, it just changes away. Or it just checks out for the line, and it detects that. So basically, we have implemented two serial ports that detects motion and that detects a line. That's pretty much it. And there is also a good memory management here. So we have used a buffer system. And yeah, that's pretty much it. But if you have any questions on the code, you can ask me.
And then we pass to Cedric.
Yeah. So I'll be speaking to you about just the motion, about how the way our boss just put it, how these the wires and circuits, the way Ro is putting it, actually functions together in an object orientation method to work together so that it can do its task. See how it's detecting something in front, looking.
You're being mean to it.
There are many advantages to this, but because most of the fix comes online.
I'll pass it back to our team leader to discuss any questions you have.
Do you guys have any question based on the coding or the vehicle? Yeah.
When it was over here, was there a way, since there was holes like in this over here, is there a way for it to detect something that's lower than the sensor?
I don't believe so because it depends. The con of it is that there are those things that they output signals, so it's kind of reduced to how big the signal is, so how big the signal is being sent out. So if they can't bounce off of it, it'll either bounce off and come back, or if the object is at a really weird angle, it'll bounce the signal elsewhere and it won't receive it. So it might run into the object.
And also, there's a problem over here. Like we didn't attack this thing because we weren't sure about it working before. So whenever this angle bends up a little bit, it detects fully. Just gets the object over here. So you have to move your legs up and down. But this is a matter of mechanical stuff. It's not like.
And did you guys research a way to kind of maybe edit that in code? Maybe give it a wider range?
Yeah, but that's the mechanical. So it's something it should be tightened to you like this,
right,
so that it just moves away. Gets the image 90 degrees.
As far as widening the range of the signal, it's mostly due to the mechanical aspects. So you need better.
And we didn't make it busy. We are not operating from Bluetooth or something like that. We just detecting motions and going away. So there is pretty much good memory for processing.
Any questions? Yeah. Okay.
So is there a way you guys can demonstrate the line tracking?
We have tried that, but it wasn't that much functioning because the line tracking is only black or white, and most of the things that we have tried are not that much fully colored. We didn't have that much black glasses or something like that. It wasn't that much working. So we kind of decided to set out to give memory for object detection.
Our strength is we communicated and to work on the code and putting the vehicle together, and we met all the team, the management rules. Some things we have to work on is timing. If we had a much of time to build the robot, we would have built it ourselves. But we have to purchase it apparently from online, just time because of time. So yeah, that's it. Thank you guys.